My name is Emma Frank, your regular tutor. We are still in the series of our teachings on mathematics. And so in this package, we are going to look at mappings and functions. I want you to bring your book and your Bible closer to you, so you can jot down the points that we are going to learn on this topic. So let's look at the format of the teaching. The subject is mathematics. And then we'll also look at the topic that we are going to take this particular package. We look at mappings and functions. Mappings and functions. Now we look at behavioral objective. At the end of this teaching, the student should be able to define mapping. The student should be able to know what function is. The student should be able to know types of functions. The student should also perform inverse of function. The student should also look at the limits of a function and know what it all means. These are the objectives. So let's look at the definition of mapping. Let x and y be two non-empty sets. A mapping is a rule. A mapping is a rule which assigns x elements of x a unique y elements of y. The set x is called the domain of the mapping. Set y is called the codomain. The codomain of the mapping. Now, the unique y which are the images of x, elements of x is known as the range of the mapping. And we should note that this range, the range is a subset subset of the codomain. The range is a subset of the codomain. Now, if F is the rule, that assigns X, element of X, a unique Y, element of Y, then we can write it. Then we can write that we can write in either of this way. In either of the ways. This way we can write it, if F is the rule, we can write it like this. F such that X maps elements to Y. You can write it this way. And then all the things we are talking, only this now tells us that this rule F is such that elements are mapped from set X to set Y. We can also write it in this way, that X, then we have F is mapped to Y. So any of these ways that we write, they still mean the same thing. But we are going to make it a very clear way where we can understand really what we are talking about. Now, to do this, we are going to illustrate it with a diagram called arrow diagram that will tell us how a rule is associating, is assigning. We consider this diagram called arrow diagram. This is set X and this is set Y. These are the elements in X. We have A, C, F, or G, H, and they have other elements here such as N, M, P, Q, R. And there is a rule which assigns element from here to here, assigns so such rule is what we call mapping, a rule that assigns elements of set X to set Y. And then we say that this particular set is called the domain, and this is the codomain. Now, the collection of these images, because these elements that are assigned to these ones, these elements that are assigned is called the range. This is what we call the range. And from our definition, we said that a subset of the codomain we said that known as that the unique Y, which are the images of X, element of X. That's what we are talking about is this one. This element is known as the range of the mapping. Now, the range is a subset of the codomain. Now you can see from here, this one is called codomain. So the range here, which are these three, that elements here are assigned to, it's called the range. So the range is a subset of the codomain. Now, let's look at types of mapping. So the first type of mapping we are going to look at is constant mapping. Now, a mapping F such that elements are mapped from X to Y is called a constant mapping if all the elements in the domain of X have the same image under F. Remember that we said those elements in set Y, that the elements in X are mapped to are called image, which is also known as the range. Now, if all the elements in the domain, all the elements are mapped to a particular element, such mapping is called constant mapping. Constant mapping. Now, another type of mapping we are going to look at is identity mapping. For every non-empty set, elements of X to the same X element of X is called identity mapping. It is denoted by example of identity mapping. Look at this diagram. If every set, every element in this set is mapped, and this particular one is equal to this one. Now, I think I can use A now. A maps to A, B maps to B, C maps to C, D is also D, and then we have here E. E will also map to E, and F map to F. Look at that. This type of mapping is what we call identity mapping. Now, remember this is the domain, and this is also the codomain. So the graph of identity mapping is a straight line from the origin. Let me show you what I'm talking about. Suppose I have, this is the y-axis, as we all know, and this is the x-axis. This is the origin. So what we are saying is, identity mapping, like we have said, we have given equation here, and it is equal to, it is written as y is equal to x. Now, if I have y is equal to x, take for instance, here y is equal to x. So if I put 1, if x is 1, then y will be 1. If x is 2, y will be 2. What it means is this: when x is 1, y will be equal to 1. When x is 2, times y is equal to 2. If I put 2, y is also 2. The same thing happens when I put 3. So whatever x is what y is. And that's why you see we have E here, and it will also be E in this place. We have B, it will also be B. Now let's look at here how why you say it is a straight line. Suppose I have 1, 2, 3, 4. These are the numbers in the x-axis, and I have 1, 2, 3, 4, and continue like that. So when x is 1, y will also be 1. Look at that. When x is 2, y will also be 2. When x is 3, y will also correspond to 3. When x is 4, y will also correspond to 4. Like that. And if you join the dot line, you see you have a straight line. That is what we are talking about. And it is identity mapping that will give you such a straight line. Now, we say the graph of identity mapping is a straight line from the origin. We have seen it from the origin at angle 45. Of course, we know that from here to here is angle 90. So you see the straight line divided equally. So it is angle 45 to the positive x, to the positive direction of x. Alright. Now, it could be written in this way, like I've shown you, to be in this way, or in this way. That is identity mapping. Now we also look at one-to-one mapping. Now, a mapping F from a non-empty set X to a set Y is set to be 1 to 1. We read it as 1 to 1, as 1 1. But when it is read, we say 1 to 1. If two distinct elements of X have distinct images under F. Now, see what happens. 1 to 1. P will also have its own image. Q also have its own image. O also have. Two elements in this domain will not have the same image, in the codomain. So everyone has its own image. That is what we call 1 to 1. Now look at the next one that we call onto mapping. And then in this type of mapping, it said a mapping is said to be onto if and only if every element in the codomain is an image of at least one element in the domain. And look at it. All the elements in the codomain, they are images of the domain. No one remains. So it can look like other ones. Some remain, meaning that all of them are codomain, but these ones are the range. So you can see that in onto mapping, the whole codomain is mapped, and the range is also the elements in the codomain. So these are the types of mapping that we are going to we are looking at. So now remember that we're trying to look at mapping and function, and so we are going to look now to function. We are looking at function. Now let's take the definition of function. A function is a mapping whose domain and codomain are real numbers. The domain and the codomain, and I want to believe by now we know what domain is and the codomain from those diagrams that we have been looking at. You see the domain, that is the set X, is called domain, and the set Y is the codomain. So a function is a mapping whose domain and codomain are real numbers. They contain real numbers. All those ones I was using variables like A, B, C, D. It's not A again. But this one we are talking about real numbers. And so such is called a function. And you should note one thing, that no element in the domain has two images. In a function, a particular element in the domain cannot get two images. Just as that mapping that we're using to explain, you see that there is no particular element that will get two images. That is the rule of mapping or function. So now let's take example. I have this set X. I have another set here called set Y. Of course, we know that this is the domain and this is the codomain. Now we have minus 1, 0, 1, 2, and then I have 0, yes, I also have 2. I also have 4. I also have 6, 8, such that look at how it is mapped. So it's mapped to this. So now, when the domain and the codomain consist of real numbers, we call it function. But there's one thing we must note, that no element here, maybe like -1, will have 0 and also have another image. No, it doesn't have any function. So function only obeys such rule. And there is no element in the domain that will not be mapped to any element in the codomain. Like most of the times we have some element left in the codomain. It can't happen in the domain. So that is one of the things. Now let's explain this concept of function. Let's explain this concept of function very well. If I want to hire something, let's look at what we can hire. Like, I want to hire a calculator, for instance, or a book. I want to hire a book. I don't have money to buy. I'm hiring. So the person giving this book says that each day the book is 20 naira. 20 naira each day. That means if I hold this book for 2 days, I have to pay 40 naira. If I hold it for 3 days, I have to pay 60 naira. Now, we can say that the cost I'm going to pay is a function of this. Now look at, let's see, it's equal to the cost of hiring a book, and then let D is equal to the days. So I can write it in this way, that C of D is equal to 20D. Now, do you know what this means? It means that the cost depends on the days. So for 1 day, if it is 1 day, then C of 1 will be equal to 20 of 1, which is 20. So that is 20 naira. And then if it is 2 days that I'm holding the book, it means C of 2 will be equal to 20 of 2, which is what? 40 naira. So you can see that the cost here depends on the number of days. So function behaves such behavior. Now, when this type of relationship exists, we see that the cost is the function of the days. That is, it depends on the days. You can see from this illustration that the money now depends on the days. If this day is 3 now, then we will have 16 naira. So it depends on the days. That is how functions behave. Now, let's look at types of function. But I don't want to go much about types of function, because as we have types of mapping, so we also have types of function. We know that we have constant mapping. That is when all the elements in the domain is mapped to a particular element here. What I mean is all the elements here, they have one image in the codomain, so we call that one constant function. And so one-to-one function, just the same. One-to-one, when one element there is mapped to a particular one. Especially, for instance, this function is one-to-one function. One here mapped to here mapped to here. It's a one-to-one function. So we also have identity function, just as we have identity mapping. we have exit function, and we have on-tail function, where all the elements, the codomain, are mapped. So it's the same thing that we have in mapping, but the difference here in mapping and function is that function talks about when we have the elements here, they are real numbers, they contain real numbers. Don't forget that no element here could be assigned to two images. Now, let's also look at one important thing I want to discover here. Remember that we said that a mapping is a rule that assigns elements from the domain to the codomain. And then when we come to function, we say that a function is a mapping whose domain and codomain are real numbers, and no elements in the domain has two images in the codomain. A mapping is a rule which assigns elements, and then a function is a mapping. So there is a rule that relates. Now, let's discover that rule here. Can we discover that rule in this thing? In this particular function, the rule here is suppose I said 2x plus 2. 2x plus 2. Now look at this rule. 2x plus 2. By the time I put minus 1 instead x, if I put minus 1 here, I will have 2 minus 1 plus 2, which is minus 2 plus 2. And minus 2 plus 2 will give me 0. Alright. Now, let me put 0 in place of x. Then I will have 2 of 0 plus 2. Now, this times this. 2 times 0 is 0 plus 2. And 0 plus 2 will give me 2. You see, we have this one, 2. The first one was minus 1. So we put in the rule, we have 0. Then we put 0, we have 2. Now, let me put 1. 2, I put 1 in the place of x. That's because x element have 1 here. So if I put 1 plus 2, I will have 2 plus 2, which is 4. Now, this one is 2. It's 2. So, 2, I put 2 in the place of x. So, plus 2. Now, this time, this is 4 plus 2. I will have 6. Now, you find out that the elements here that are assigned, these ones from here to here, which is the range, that a particular rule that generates this element is 2x plus 2. So, I can write it like this, that y is equal to 2x plus 2. So, it's easy in form of equation now. So, that is how it generates from there. That is the rule. This one is what we call rule. This rule that is assigning this value. So it's very, very important. Now, we are going to look at another function again and also discover the rule that these things, these elements in the domain and codomain are assigned. Let's look at another function. Now, let's look at another function. Suppose there is a rule such that if elements in x, set x, and then I also have set y, and then I have minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the elements 2, 3. And I have then I also have 5. I also have 2. Yes. And I also have 1. And then minus 3 is marked to 10. 2. Minus 3 is marked to 5. Minus 1 is marked to 2. 0 is marked to 1. I also have that 1 is marked to 2. 2 also is marked to 5. And every 3 is marked to 10. All the elements in the domain is marked, which is one of the laws of function. There is no element that can remain in the domain. If it does so, then it is not a function. And then here we have the co-domain. Remember, there is a rule that marks this function. Now, let's discover this rule. If we look at this particular rule, we see that the rule is x squared plus 1. Now, in x squared plus 1, if I put minus 3 squared plus 1, then here I will have 9 plus 1, which is 10, which is this. Now, minus 2. If I have minus 2 squared plus 1, I will have 4 plus 1, which is 5. And it maps to this one. Now, I have here minus 1 squared plus 1. Of course, it will be 2. That's how this one maps to 2. What about 0? I have here also 0 squared plus 1 will give me 1. So that's how 0 is mapped to 1. Same thing happens to 1. If I put only 1 squared plus 1 will give me 2. So you can see how 1 is mapped to 2. Now if I put 2 squared plus 1, I will have 4 plus 1, which is 5. Alright, so 3, same thing happens. 3 squared plus 1 will give me 9 plus 1, and it is 10. So 3 mapped to 10. Now, this particular rule, we can place it as coordinates. We can put it as coordinates. So, anytime I want to write, since this rule is x squared plus 1, I can say that the rule that maps this function is y is equal to x squared plus 1. That every element here y, that the rule is x squared plus 1. That is what will give me this element of y. Any element of y, the rule is y is equal to x squared plus 1. So, that is the rule, another rule that we have discovered. So, as I was saying, that you can place this in as coordinates. I want to put it as coordinates. I was saying that we can put it as coordinates. Now, this is minus 3. So, write minus 3 and 10. In this coordinates, minus 3 is marked to 10. Then I have again minus 2 and 5. Don't forget to put this comma to separate them. Then I have again minus 1, 2. Then I have 0 and 1. And I have again 1 and 2. I also have 2 and 5. And I have 3 and 10. Now, observe it that every element, this entry element, these ones, are the domain, the elements in the domain. And no element here will resemble. No element. We have minus 3, minus 2, minus 0, 1, 2, and 3. Of course, minus 3 is not the same as 3, and minus 2 is not the same as 2. So that is what we are saying. But in this y, the y coordinates, two elements can have the same, it doesn't matter. Like here we have 10, we have 10. But very important is that the x elements cannot be the same. And this is in coordinate form that we have it. And this same information, we can transfer it and place it as graph. So we want to place this coordinate, the coordinate now, in graphical form. Now we see that in this particular place, when x, of course you know this is x and this one is y. So when x is minus 3, we have that y is 10. And then we know that in our graph paper that this vertical axis is y axis and then this horizontal axis is x axis. So we can put on graph now. Look at how we are going to put. When x is minus 3, we see that y corresponds to 10. So we mark something here. Then when x is minus 2, y is 5. So we have 4 here, we have 6 here. So 5 is in the middle of 4 and 6. So we trace it to this place. So at minus 2 we have that y is 5. Now when x is minus 1, y is 2. Yes, minus 1. So we have 2. And then when x is 0, y is 1. Is 0. So y will be here. 1 is here. Since this is 2. So when x is 1, y is 2. Back to here. Which corresponds to the y-axis. And when x is 2, y is 5. When x is 2, we have y is 5. Okay? So 5 will be somewhere here. Y is 5. Then when x is 3, we have that y is 10. So somewhere here. Alright. So we can now join these points. And then we have something like that. So you can now see that each time, remember that the rule that gives us this particular graph is y is equal to x squared plus 1. Now, you see the equation is in equation form, which is quadratic. That's the quadratic. And the quadratic equation will give you a parabola. But I'm happy that you know how this rule was generated. And from now, when you are looking at the equation, your mind should reflect on function or mapping. That is how this rule is generated. So we are going to now look at other subtopic. So we are looking at algebra of function. Algebra of functions. Now, like we have addition, we also look at subtraction. We also look at multiplication. So we look at division. So first, let's look at addition and subtraction. Let f and g be two functions such that f of x is equal to 3x squared minus 2x plus 1. This f of x is equal to this. It's just like we just had the first one. The first rule that we saw was y is equal to 2x plus 2. And then this last one, we saw how y is equal to x squared plus 1. So I can write it as f of x is equal to 2x plus 2. So you see the same thing as writing y. Now I can write it as g of x is equal to x squared plus 1. To separate these two functions, that they are different functions. So I call one f, I call this g. That is what we are doing. So let's such that f of x is equal to 3x squared minus 2x plus 1. So this is a rule we should know. Now we also have that g of x is equal to x squared plus 4x plus 5. Right. So we are going to find number 1, we will find f of x plus g of x. Number 2, we look at g of x minus f of x. Now let's take the solution. Solution I f of x plus g of x will be the same. You know, f of x is 3x squared minus 2x plus 1 plus, so we can use the form of adding real number, plus we put g of x, which is x squared plus 4x plus 5. Now if we add them, we will have 6, and then this one will give us 2x, then this one will give us 4x squared. So we see that f of x plus g of x, to add these two functions, I give you 4x squared plus 2x plus 6. So that is how two functions are added. Two functions, and you add them. Now we can also look at subtraction of it. That is I. Remember this one was I. So for I we have g of x minus f of x. Now this will be done in two ways. The first way I'm going to do g of x. Now g of x is x squared plus 4x plus 5 minus, can still put it in this way, minus f of x, which is 3x squared minus 2x plus 1. Now if I do that, 5 minus, no, this minus is affecting this one. So 5 minus this will give me 4. Now 4x minus 2x give me 6x. Then I have here x squared minus 3x. I will have minus 2x squared. So that is g of x minus x. So I can also subtract it in this way. I will have x squared plus 4x plus 5 minus f of x, which is 3x squared minus 2x plus 1. Now remember that here the minus affects this one. So we have 3x squared plus, because this time this will give us plus 2x minus 1. Now if I collect them, look at x squared minus 3x squared, so we have minus 2x squared, then this and this, that is 4x plus 2x will give me 6x Then 5 minus 1 will give me plus 4. Then compare this. So we are looking at multiplication of functions. Yeah. Given that p of x is equal to 5x cubed plus 3x squared minus 2x plus 6. And we have that cube of x is equal to x cubed plus 4x squared minus 3x plus 1. So we are going to find p of x times cube of x. So in this way, we also have two patterns I'm going to show how you can multiply these functions. Method 1, you can do it in the same way we can arrange three numbers x plus 4x squared minus 3x plus 1. You can put it this way. So in this particular way, 1 times 6 will give us 6. 1 times minus 3x will give us minus 2x. 1 times 3x squared will give us 3x squared. And then of course this will have 5x cubed. Now this particular one, minus 3 times 6 will give us minus 18x. Minus 3 times minus 2, minus 3x times minus 2x will give us 6x squared. So we have 6x squared minus 3x times 3x squared give us minus 9x cubed. So minus x times 5x cubed will give us minus 15x raised to the power 4. Right. Now we can also use this one as 4x squared. 4x squared times 6 will give us 24. 24x squared. 4x squared times minus 2x will give us minus 8x cubed. We have minus 8x cubed. Then 4x squared times 3x squared will give us 12x raised to the power 4. Then we have 4x squared times 5x cubed give us 20x raised to the power 5. Right. Now we can also go for this one as x cubed times 6. X cubed times 6 will give us 6x cubed. We have 6x cubed. X cubed times minus 2x will give us minus 2x raised to the power 4. X raised to the power 4. So, and then we can use this x cubed to times this particular one, that is x 3x squared. We'll have 3x raised to power 5. 3x raised to power 5. 3x raised to power 5. X cubed times 5x cubed will give us 6x raised to power 6. That is x cubed times 5 will give us 5x raised to power 6. Alright, now if we add this, we will have 6, and we will have minus 20x, and this particular one, this plus this is 9. 9 plus 24, we will have 33. Have 23, so we have plus 33x, 33x squared. Now here we have 5 minus 9, so we have minus 4. So minus 4 minus this will give us minus 12. Minus 12 plus 6 will give us minus 6x raised to the power 3. Here is minus 15. So minus 15 plus 3 we have minus 3. Minus 3 minus 2 we have minus 5x raised to the power 4. Same thing happens here. 20 and we have 3. So what we have here is 23x raised to the power 5. So here we have 5x raised to the power 6. Look at that. This is the way we can multiply it in that method. But we have another method also that we are going to look at. But another method. Let's look at this particular method. You can do it in this form: 5x cubed plus 3x squared minus 2x plus 6. Then we bracket it and we pick each term. So I'll pick the first one, x cubed. Then the second one is 4x squared. Then I will still write back my function, this particular function is 3x squared minus 2x plus 6. Then after that, when you pick the third one, is 3x, and then 5x cubed plus 3x squared minus 2x plus 6. Right. Now, I'm going to also pick last one there, which is 1, 5x cubed plus 3x squared minus 2x plus 6. Now, I will multiply from the first one. So this times this will give me 5x raised to the power 6. X cubed times 3x squared will give me 3x raised to the power 5. Yes. And so x cubed times minus 2x will give me minus 2x raised to the power 4. X cubed times 6 will give me plus 6x raised to the power 3. That's the first one. So also go again for the second one. 4x squared times 20x cubed, times 5x cubed gives me 20x raised to the power 5. 4x squared times 3x squared will give me 12. 12x raised to the power 4. 4x squared times minus 2x give me minus 8x raised to the power 3. 4x squared times 6 will give me plus 24x squared. So the second one has finished. And we enter the third one here. And so minus 3x times 5x cubed. That will give us minus 15x raised to the power 4. Okay, minus 15 minus 15. 15x raised to the power 4. Now, minus 3x times 3x squared will give us minus 9x raised to the power 3. Minus 3x times minus 2x will give us plus 6x squared. And then we have minus 3x times 6 will give us minus 18x. Right. So we can go for the last one. Of course, this is 1, and then whatever this times in this, we will still have the same thing. So that is 5x cubed plus 3x squared minus 2x plus 6. Alright. So here we are going to add them. I'm going to do that to have 6. We have minus 20x. Then here, this is 24 plus this is 30 plus this we have 33x squared. Then here we have minus 8 minus 9 give us minus 17. And then minus 17 we have 11 here. Minus 17 plus 11 will give us minus 6x cubed. The next one there we are going to look at is this particular power that 5 power 4. So we have minus 2 minus 15, that is minus 17, plus 12 will give us minus 5x raised to power 4. So in this particular power, the one that has power 5, we have 23x raised to power 5. And so we have 5x raised to power 6. Now, in this method, compare this with this, you see, they still have the same answer. So any of the methods can really work. Let's look at division. So we are looking at division of functions. Now, given that f of x is equal to x cubed y squared plus 2x squared y minus 3x cubed, and then g of x is x squared y, we are asked to divide f of x by g of x. Now, the second one, if we are given that h of x is equal to 6x cubed minus 5x squared plus 4x minus 1, and then p of x is 2x squared plus x minus 3. Now, we are also going to find h of x divided by p of x. We are still going to divide it. Now, let's start with 1. Solution 1. Now, x cubed y squared plus 2x squared y minus 3x cubed is divided by x squared y. So it means division. We can divide it as x squared y. All this ones x squared y is divided through written here. So x squared y. That means in this particular case, we can next thing is what we have x cubed y squared. I'm going to take this one up. Of course, if I take that up, I will have x minus 2. If I take this one up, I will have y minus 1, which we know according to law of indices that we are going to collect the ones that have the same base. Now, in this one, we have 2x squared. Taking this one up, we have x minus 2. Taking this one up, we have y. Y is already here, so we take another one up. We have y minus 1. In this term, we have 3x cubed. So we have x squared here. We take it up, we have x minus 2. Of course, there is no y here, so we can leave this one here. Now, what it means is that collecting this term and this term that have the same basis, according to law of indices, we have x, because this is x. I mean, this is raised to power 3, and this is minus 2, so you remain 1. So you have only x here. Same thing happening here. So you have x, y. Here is 2, and here is minus 1. So you remain 1 plus. Now, in this term, we see that this is 2, this is minus 2. So we add them, we have x raised to 0, which is 1. So 2 times 1 is 2. The same thing happening here. We have 1, we have minus 1. So x raised to 0 is 1. So everything here we have is 2 minus. Of course, here is, we have y times here. So here is power 3, here is minus 2. So we have 3x all over y. So we can divide it in such pattern. If we don't want to go on that way, for number 2, we can I can use another pattern, and that is a long division method. Where number 2 is solution 2. Remember this one was 1. So for 2, if I use long division method, h of x is 6x cubed minus 5x squared plus 4x minus 1. And then p of x is 2x squared plus x minus 3. Now, 6x divided by 2x squared will give me 3x. 3x half plus 6x cubed means 6x, x, and x. So divided by 2x, x. 2x squared, 6x cubed. So this cancel this, cancel this. And then this 6 divided by 2, we have 3. Then this x. So we have 3x. Now, 3x times 2x squared will give me 6x cubed. 3x times x will give me plus 3x squared. 3x times minus will give me minus 9x. So I'm going to subtract. If I subtract, I'll have minus 1. And then here, I will have 4x minus 9, which will make it plus. So I have plus 13x. And then same thing happening here. I have minus 5 minus, because that minus affects this plus. So I have minus 5 minus 3. So that will give me minus 8x squared. That's what we give. Now, I'm going to divide minus 8x squared with this. And if I do that, I will have minus 4x. And by that minus 4x times 2x squared. Okay, minus 4. I think minus 4. Just minus 4. So minus 4 times 2x squared will give me minus 8x squared. Now, minus 4 times x will give me minus 4x. Alright. So minus 4 times minus 3 will give me plus 12. I'm going to subtract it again. So minus 1 minus 12. You know, there is minus sign because I'm subtracting. So we have minus 13. And here, 13 minus 4x give us 17x. Let's look at this again. Can anything go here? So it can't go. And then so here, this is the remainder. This is called remainder. This is the remainder. So that is the division pattern, and this is what the divisor. Call this one divisor. So we have the quotient. You can watch a package for polynomials to get a full detail of how you can divide functions. So we are looking at composite functions. Let f is such that x maps to z and g such that z map to y. The two functions. Such is called composite functions or function of a function. Example, we have our set, let's know our set is here, set x. We also have set z, and then we also have set y. And we know that this is the domain. Now, see what happens. In this particular one, if we have elements here, maybe 2, we have 3, 4, 5. And then we have elements also here, the minus 1, 3. Okay, minus 1, minus 2, 1. We also have 6. We have 7, 9, 10, 11. And there is a rule that assigns element from here to here. Assign to here. Right? And this also assign this element is in this form. Got that? So these elements here are assigned to a particular element, and here is also assigned. Automatically, this is the domain, and then this is the co-domain. But this one also becomes the domain of this rule. Remember, there's a rule, and this one is rule G that is assigned. This one is F. So it means here that's supposed to be the domain of only here is now the co-domain. It's supposed to be the co-domain. So it's the domain. Is the domain. Is the domain. And this is the co-domain. What it means is that this is the domain that assigned, and instead of here being the co-domain, this one is also a domain, is assigned to another one. Automatically, X depends on Y. Whatever X is given will be what Y will have. So now, like I said, this function is function of a function. X depends on Z, and even Z depends on Y. Now, another illustration about function of a function is, if I have a friend and then I am also depending on somebody else that is giving me money, and after getting the money, I will use the money also and give to my friend. Automatically, my friend is a function of a function, because even I myself am a function, that means I depend on somebody, and the other friend is depending on me. That is what happens here. So I stand at the middle now, depending on X, and then what automatically it means is that while it is here, my friend depends on me. Alright. So that's how that relation looks like. Now we are going to see how we are going to transfer this and put in algebraic function and see how we can solve problems related to composite function. Now, if F is a function and G is a rule, and G is also a rule, so composite function, we can write it in this way: F composite G. That is how we pronounce F composite G. Or I can also write this way: F also F composite G, meaning that I'm putting G into F, and F depends on G. So suppose I can also do the reverse way. I also put F into G, and we call G composite F. Or I can write it this way: G composite F. So let's look at these functions and see how we can solve composite functions. Let's take examples. Now, let's look at this example. Let f of x is equal to 2x squared minus 3. And then g of x is equal to x plus 1. We're going to find, number 1, g composite f. And so we also have f composite g. Let's get the solution. For I, g composite F. We know that f of x is 2x squared minus 3 and g of x is x plus 1. So we are going to put f, this particular one, f of x, into g. So that is already g is this. So we'll put this anyway, you see x. Bring f of x and put in the x of g. So we'll have 2x squared minus 3 plus 1. And what we need is the whole function, the whole of this function will enter here, which is x. That is what it means. F of x g composite f. Carrying this one and put into g. So everything here is entering g, which is this place of x. And this one is the element of g that remains. So if we do this, we will have 2x squared minus 2. So that is g composite f. We can also look number 2, f composite g. So f composite g will be the same as taking g and put in f. So we know that f is 2. So in this place of x, I will bring g and fix it there. So I will have x plus 1 squared, then minus 3. So what this will give me is, I'm going to expand this by binomial expansion. So I have x squared plus 2x plus 1 minus 3. You know, this place by binomial expansion, you can get that. Because this place, x plus 1 squared, is the same thing as writing x plus 1, x plus 1. So this times this will give you x squared, x times 1 will give you x, and then 1 times x will give you x, 1 times 1 will give you 1. So if you add up, you have x plus x is 2x plus 1. So this particular one is what I'm doing here. But binomial, you can just do it very short, the way I just put it, without going through this process. Now, after that, I'm going to multiply. When I multiply here, we have 2x squared plus 4x plus 2. As 2 times this will give me this, 2 times this will give me this, and 2 times this will give me this, minus 3. Now, what this means is that I have 2x squared plus 4x minus 1 plus 2 minus 3, give me 1. So that is f composite g is equal to this. So this is how we solve composite function, putting one into the other. And don't forget that it's also known as function of a function. So we have another example. If f and g are functions of x such that f of x is equal to x plus 2 and g of x is equal to 2x squared plus 1, find the value of x for which f composite g will be equal to g composite x. G composite f, sorry. Now, let's take the solution. The first thing we are going to do is to look for f composite g. So, f composite g will be equal to, we are going to put g in f. And so, what will happen is, we'll put this in this. And then we'll have 2x squared plus 1 plus 2. So that means we have 2x squared plus 3. We're putting this one in the place of x. Right. Now, we also look for g composite f. Then that is to put this one inside this. And then I will have 2 brackets x plus 2 square, it's in a square. I'm putting the whole of this in the place of x. So I have to square it plus 1. If I expand this by binomial expansion, I will have 2x squared plus 4x plus 4 by binomial expansion. That is to write x plus 2 and x plus 2 and times it. It will give me this particular place. I'm using binomial expansion now to do that. So plus 1. Now I'm going to use this to times this. I will have 2x squared plus 8x plus 8 plus 1. So what it means is that 2x squared plus 8x plus 9. So this is 9. Now the question is, which value of x will make f composite g equal to g composite x? Alright. So for us to get the value, we are going to equate f composite, g composite f, and we also equate f composite g. That is 2x squared plus 3 will be equal to 2x squared plus 8x plus 9. These two. And we will do that by collecting like terms. Collecting like terms, we will have 2x squared minus 2x squared, as this crossing to this way. And then we also have 9, let me bring 9 to this side. I will have plus 3 minus 9 will equal to 8x. Now automatically what it means is that this one will go. So I'll have 8x will be equal to minus 6. Look at that. 8x will be equal to minus 6 because it's 8x. Now 3 minus 9 gives us minus 6. So x will be equal to minus 6 divided by 8. So 2 can go here 3 times and 2 can go here 4 times. So we have minus 3 all over 4. Now this is the value of x. So we are looking at inverse function. Now let a function be defined by the arrow diagram such as this. So we have set x and we also have set y. If there are elements in the domain, say minus 2, 3, 4, 5, and then we have 6, 8, 1, 3, and a rule exists where these elements are assigned. Remember, like the rule F, and this is the domain of this function, and this is the co-domain. Now, if the co-domain become the domain, I'm going to turn this thing like this. That's what we call inverse, where this one become the domain. If I do that, then I will have in this form y, then we'll have set x. Now I will have 6, 8, 1, 3, I have minus 2, 3, 4, and then 5. So in this particular one, the functions will look in this way. So this is a rule that exists. So you write this one as f inverse f raised to power minus 1. So this is now the domain, and this is the co-domain. You can see that. So this is the inverse of this function. We just bring the co-domain now, becoming the domain. Now, as it is, remember that we are using this f raised to power minus 1, that is the f inverse, is equal to this. We turn this one to the other side. So that is the inverse. But let's look at algebraic method of finding inverse of a function. So we can do it algebraically using this example. Given that f of x is equal to x all over 2 minus 5 and g of x is equal to 3x plus 2 all over 2x minus 5, we are going to find f inverse, that is inverse of this function, and we also find g inverse. So let's start. I will let y is equal f of x. Of course, we know that we can use y here, so that we will have solution 1, solution I, that is the first one taken. So we can have that y is equal to x all over 2 minus 5. Now, look at this. From the way we turn this thing, this one was like this. And then we turn it and put y this way and put x, set x this way. So that is the same thing we are going to do here. We are going to replace, okay, so we'll have x is equal to y all over 2 minus 5. Now, here we are going to have y all over 2 to be equal to x plus 5. You know how I'm taking this one to the other side, so we'll have y all over 2. Now, what it means is that y will be equal to 2 bracket x plus 5. I'm typing this with this. So remember that y is equal to f of x. So I can replace that f of x inverse as inverse of f is equal to 2x plus 5. So this is the inverse of this particular function. Now, let's look at example 2. The solution for I. We have that g of x is equal to 3x plus 2 all over 2x minus 5. Now, we also let g of x is equal to y. I'm putting this y so that we can really see it in the actual way of x set and y. Now, as usual, we are going to turn. I want you to imagine how we turn that two set. So we are going to turn the set now and bring y into x side, and then we carry set x into y. So that what does that mean? I'm going to replace y anywhere I see x. I'm going to replace x anywhere I see y. Don't forget that this thing is like this. Y is equal to 3x plus 2 all over 2x minus 5, since I am letting g of x equal to y. So when I replace, I will have, look at that, x in the place of y will be equal to 3y plus 2 all over 2y minus 5. Now, if I cross multiply this thing like this, I think I will have 3y plus 2 will be equal to x bracket 2y minus 5. Now, if I times this, open this bracket, I have 2xy minus 5x. So I have 3y plus. So, collecting like tens, we'll have that 5x plus 2. I'm taking 5x back this way. 5x plus 2 will be equal to 2xy minus 3y. Like that. So what it means is that 5x plus 2, something is common here, so I can factor out y. 2x minus 3. So we're going to make y subject of the formula. So we'll have that y will be equal to 5x plus 2 all over 2x minus 3. Remember that y is equal to g of x. So we'll have g of x inverse is equal to 5x plus 2 all over 2x minus 3. Don't forget the pattern. Just replace y in place of x and then place x in place of y. Then you start solving for y. Finish. Let's look at example where we will look for the domain of a function. We also look for the range of a function without drawing the two diagrams, the arrow diagram. That is the two sets that we normally draw. For instance, two functions are defined by this. Look at the first function, look at this one. Where x is a real number and this symbol denotes the non-negative square root. We are going to find the largest domain and the corresponding range of each of the functions. Number 2, we are going to find the inverse function, that is g inverse, and the composite function. I think we apply composite function. Composite function, that is f composite inverse of g. We're going to find it. So let's look at the solution a bit. We have let y is equal to this 4x minus x squared. Now we want to find the domain of this function. Remember that the domain is always in the set x. So, and from the question we know that this square root denotes non-negative square root. Honestly, the square root of negative number is not defined. To press your calculator, square root of minus 4, for instance, will tell you mass error, so it's not defined. So anything that we make here to give negative number is not defined. Now, if we put the value of x here, we put, for instance, let's start on minus 2. If we put minus 2 here, then we'll have minus, see what we have? We have 4 minus 2 squared. And that will give us 4 minus 4. Because this place will be 4, which is 0. And square root of 0 is defined. So minus 2 now is the domain, is in the domain x. If I put minus 3, for instance, I will have 9 here. Because this will be minus 3 squared, will give me 9. And 4 minus 9 will give me minus 5. You see, negative square root, it won't work. So minus 3 is not in the domain. And same thing will happen. If I put 3 here, I will still have 9. So 3 is not in the domain because it will give me minus. So in the domain now is minus to 2 that will work in this place. So you can now write that the domain is minus 2 less than equal to x and less than equal to 2. So that is the domain. And I want to believe you know how we get the domain, putting the value in the place of x, because the domain is always x. But if we do that, you see, by the time we put minus 2 in this, we will have 0. And square root of 0 will give us 0. So that is the range. We'll get 0. So the range is 0 is less than equal to y. That is the first thing, minus 2. So if we put 1, minus 1, we'll get positive result. By the time we put this one, 2, into here, you get 0. Remember at minus 1 we get 1 point something. So it's less than equal to 1. This is the range. So this At that particular domain, we fix it here. The only range that you get is this. So you can see how we write this range now. We are not using the other set today, but we are writing it in this way. That will tell the range of this function and then the domain of this function. Now, for the second function where we have this I, okay, the second function we have that y is equal to 1 over x plus 4. Now, we want to find the domain, but there is one thing we know about any number in rational form, that the denominator of this number, if it is 0, is not defined. Any number divided by 0 is not defined. So your calculator, if you press any number divided by 0, it will tell you mass error or undefined. So for that, we will have x plus 4 will be equal to 0. Let's equate it to 0 and know the domain. And if we do that, you see that x is equal to minus 4. So if here is minus 4, the function will be undefined. And so the domain now, the domain is all values of x, real numbers, except minus 4. Because if minus 4 is here, it won't work. So the domain is all real x except minus 4. Now what about the range? The range is all real number except 0, because 0 is not here, except 0. That is. So that is the range. That is the range. So we can use this pattern also to find the range and the domain. Right. So we will also look at question 2. We are asked to find the inverse function. G inverse and the composite function. F composite G inverse. Now we are going to look at it in this way. We are going to find inverse first. We know that G of x is equal to, from the question, is equal to 1 all over x plus 4. Now we let G of x is equal to y, so that we can replace our values. So y will be equal to 1 all over x plus 4. Now we still remember how we can take inverse from when we started from diagram and when we change the set from set y now becomes the domain and set x becomes the codomain. So, and we have done that up to the level where we know that if we want to take inverse, we will just replace this by x and replace this by y. That is equivalent to changing those two sets. So we will now replace it that way, and we will have x be equal to 1 all over y plus 4. Yes. And if this happens, then what we will have here is, if we cross multiply this, we cross multiply it, we will have x bracket y plus 4 be equal to 1. So I can multiply this and this times this. So, and that will give me xy plus 4x to be equal to 1. And remember that what I really need is y to stand alone. So what I will do is, I'm going to transfer this one to this side, and I will have that xy will be equal to 1 minus 4x. Transforming this one here. That is y only will be equal to 1 minus 4x all over x. Now remember that g of x is equal to y. So I will have that g of x inverse is equal to 1 minus 4x all over x. So that is the inverse of this function. That's the inverse of this function. Now, the next question says that we should find G composite G inverse. G composite G inverse. Don't forget that f of x, okay, f composite G inverse. Don't forget that f of x is equal to square root of 4 minus x squared. And then we have G inverse. So G inverse, G of x inverse is equal to 1 minus 4x all over x. Now that we want to find f composite G inverse, we are going to put G inverse inside, the G inverse inside f. And if we do that, it means we will have that f composite G inverse will be equal to, look at that, 4 minus, now in this place of x squared, I will substitute the rule of this. So we have 1 minus 4x all over x squared. That is how it is. So, and if that happens, I will now expand here by binomial expansion. So we have square root of 4 minus, expanding here will give me minus 1. Whether 1 minus 8x okay, plus 16x squared all over x squared. Yes, that is how this place will be when expanded. This square will times it and also times this. So we have x squared, the downside. Now, if I take LCM of this, remember that this is another part, this is 4, and this is over 1. So I can take LCM of this. And if I do that, I will have 4x squared minus, of course, everything here will still be the same as this. So what I will have is minus 1 plus 8x because of this it times this become plus 8x, then minus 16x squared all over x squared, which is the same as now 4x squared. So that 4x squared minus 16x squared will give us minus 1 all over. That is it. Minus 12x squared, plus 8x minus 1 all over x squared. So this is f composite G inverse. That is how it is solved.